the prism is placed in the air, a ray PQ of monochromatic light is incident on surface AB of the prism. This ray of light is refracted at point Q and advances in QR direction, and it is again refracted at R on the surface AC and emerges out in air in RS direction. MQL and NRL are the normals drawn to surfaces AB and AC at points Q and R respectively. When the incident ray PQ is extended, it seems that it advances in PQDE direction. When emergent rays RS is extended backward, it meets PE at point D. Here, the angle between the direction of incident ray and the emergent ray, angle EDS, is equal to delta, is called the angle of deviation, delta. Now, let us find the relation between angle of prism A, angle of incidence I, angle of emergence E, and angle of deviation delta. For triangle RDQ, the external angle EDS is equal to delta, and angle DQR and angle DRQ are corresponding internal angles. Therefore, angle EDS is equal to angle DQR plus angle DRQ. Therefore, delta is equal to, in brackets, angle DQL minus angle RQL plus, in brackets, angle DRL minus angle QRL equal to I minus R1 plus E minus R2. That is, I plus E is equal to delta plus R1 plus R2. In square AQRL, angle AQL and angle ARL are the right angles. Thus, A plus angle QLR is equal to 180 degrees. For triangle QLR, angle QLR is equal to 180 degrees minus, in brackets, R1 plus R2. Therefore, A plus 180 degrees minus, in brackets, R1 plus R2 is equal to 180 degrees. Therefore, A is equal to R1 plus R2. Substituting the value of R1 plus R2, I plus E is equal to A plus delta, giving relation between I, E, A and delta. Refractive index of the prism. The graph of experimentally measure values of the angle of deviation, delta, against the value of angle of incidence I is shown as. From the graph, it is clear that the value of the angle of deviation, delta, becomes minimum for only one particular value of the angle of incidence I. It has been experimentally established that for any given prism, the ray for which the angle of incidence and angle of emergence are equal, the angle of deviation is minimum for that ray. The angle of minimum deviation, it is denoted by delta m. Thus, when I is equal to E, delta is equal to delta m. If I is equal to E, sin I is equal to sin E. The general form of Snell's law, N1 sin theta 1 is equal to N2 sin theta 2. For the refraction of light at AB and AC surfaces of the prism. For AB surface, N1 is equal to 1 in brackets air. N2 is equal to N in brackets prism. Theta 1 is equal to I. Theta 2 is equal to R1. Therefore, sin I is equal to N sin R1 for AC surface such that N1 is equal to N in brackets glass. N2 is equal to 1 in brackets air. Theta 1 is equal to R2. Theta 2 is equal to E. Therefore, N sin R2 is equal to sin E. For equations, we get N sin R1 is equal to N sin R2. Therefore, R1 is equal to R2 is equal to R. For equations, R is equal to A upon 2. For equations, I plus I is equal to delta M plus A. In brackets, if I is equal to E, delta is equal to delta M. Therefore, I is equal to A plus delta M upon 2. Substituting the values of R and I from equation into Snell's law, N is equal to sin I upon sin R, we get N is equal to sin A plus delta M upon 2, the whole upon sin A upon 2. Using these experimentally determined values of A and delta M, refractive index N of the material of prism can be calculated. The refractive index of the material of prism is 1.5. The angle of prism is 60 degrees. Find the angle of minimum deviation for the prism. N is equal to 1.5. A is equal to 60 degrees. Delta M is equal to N is equal to sin A plus delta M upon 2, the whole upon sin A upon 2. Substituting the values of N and A in this equation, 1.5 is equal to sin 60 plus delta M the whole upon 2 upon sin 30 degrees. Therefore, 60 degrees plus delta M the whole upon 2 is equal to 1.5 into 0.5. In brackets, because sin 30 degrees is equal to 0.5 is equal to 0.75. Therefore, 60 degrees plus delta M the whole upon 2 is equal to sin raised to minus 1, 0.07500. Therefore, 60 degrees plus delta M the whole upon 2 is equal to 48 degrees 35 dash. Therefore, delta M is equal to 37 degrees 10 dash.